Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good morning to all of you. First of all, I would like to thank everyone for joining our webinar series today. Ladies and gentlemen, before we begin our webinar today, let's recite our Ummul Kita Al-Fatihah. Amin, 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 ya Rabbal Alamin. Hi, my name is Mazlina Pati, the moderator for the today's session. I'm very pleased to see you here and welcome all to the Faculty of Information Management Webinar Series 2022. For your information, this webinar is available through Facebook Live at facebook.com/UiTMFPM. And just a little reminder before we get started, if you have any questions during the presentation, please feel free to type them into the chat box and I will bring them up during the Q&A session after the presentation ended. Ladies and gentlemen, this webinar is organized by the Center of New and Emerging Technology Research for Information Science, which is also known as a CITRIS, and supported by the Faculty of Information Management UiTM Puncak Perdana Campus. This webinar today will discuss about 3D documentation method in the preservation of historical artifacts and building in Malaysia. Before the presentation begins, let me introduce our guest speakers, Assistant Professor Dr. Harlina Mat Sharif. Ladies and gentlemen, Dr. Harlina Mat Sharif is a senior lecturer at Kuliah of Architecture and Environmental Design at the International Islamic University Malaysia, IIUM. She earns her PhD in Islamic Arts and Archaeology from School of Oriental and African Study, SOAS, at University of London in 2013. With her research focusing on the morphology and idiomatic expressions of mosques in island Southeast Asia. Her early education was in architecture with Master of Science Design and degree in majoring in computer in design. Her professional training is mainly in computer graphic application in design, both as a designer as well as an educator while living in Sydney, Australia from 1919 to 1997. Her passion in Islamic study has brought her to study Arabic in Egypt in 1997 and then in Jordan in 1998 to pursue a diploma in Islamic jurisprudence, Sharia. As a doctorate student in University of London, she discovered that her linguistic skill in Malay, English and Arabic were instrumental in enabling her access to many resources pertaining to the study of the origins and developments of mosque architecture in the mainland Arabia and relate it to the research of Islamic identity of the Malay world. So her research interest is in the area of impact of culture exchange and maritime network to the traditional Malay Islamic design and heritage, as well as the applications of digital technologies, visualizations, and documentation of the culture heritage. Okay, without further ado, I would like to welcome our speakers today to deliver her presentations. All right, Dr. Harlina, the floor is yours.
Okay, thank you so much, Dr. Mazlina, for the nice welcome and also introduction for myself. Okay, inshallah, we'll start without further ado. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, everyone. Okay, I think my screen is up. Yes, Dr. Mazlina?
Yeah.
Everybody can see my screen, yes?
Yes.
Okay,
Now we
then
can
thank you
see
so
it.
much. Yeah, okay. Okay, so just a short sort of like introduction on where I come from, meaning to say that why do I do this sort of. We in the International Islamic University Malaysia, we have a department called Department of Applied Arts and Design, which is parked under the Kuliah of Architecture and Environmental Design. In this department, we offer programs of applied arts and design with three majorings. One is interior design, two is industrial design, and the other one is heritage conservation and technology. So this is the majoring in which that I am responsible for, and I've been like overseeing it for the past few years. Okay, so the three documentation methods in the preservation of historical artifacts and buildings in Malaysia, the title of the talk today, is mainly I guess knowledge sharing lah, yeah, knowledge sharing of all of the years that I have spent together with a group of people, looking into the methods on how historic buildings and also artifacts can be preserved in a digital way, or what you call as digital preservation. Okay, so these are the contents of the talk today. So the question is, why digital heritage? Perhaps a few years back, this would have been the question, but with the COVID pandemics and things like that, that everything went digital. So I guess it is now, and in fact, Malaysia is a bit ketinggalan, lah. I mean, a bit behind in terms of digital heritage. Second, issues in the current practice of heritage documentation in Malaysia. Third, methods, technologies, and experimentations, where I will share with you what we have been doing over the years, and then basically, with collaborations with external parties, but also, through students' projects in Department of Applied Arts and Design. And for advantages and opportunities, the things that we look forward to, the things that we think, you know, are ripe to be tapped at this current moment. And we end with a conclusion, inshallah. Okay, so why digital heritage? Cultural heritage is core to a nation's self-respect and identity, and without it, the history can be influenced for reinterpretation, or even rewritten. Yeah, many of our cultural heritage assets are left undocumented and unknown to the public. Thus, the awareness for the preservation of cultural heritage has brought exploration of new sustainable methods, one of them being digital heritage. Yes, if you look at the way that Malaysia is being built, with the different sort of like components in the society, and there seems to be a strife on which components that people want to highlight. Therefore, if we are not doing something to our cultural heritage, if we are not highlighting what is our roots or our background, then this history could be wiped off. Yeah. So there's a danger when we do not protect our cultural heritage. Therefore, with Malay cultural heritage in particular, as I mean, our buildings are built, using wood, and they are perishable materials. They're not so much managed.
We having some issues here. Kita uh, kita tunggu sekejap.
Hello, Assalamualaikum. Saya tertendang je.
Terkeluar.
Okay. I just realized because like the camera was not on, so I was like calling your name, Dr. Mazlina. Where are you? Okay, all right, come. So do I just start talking, or how?
Doctor can continue.
Continue, yeah?
Yes.
The last time tu I kat mana tadi? Baru dekat starting ke?
Yes, dekat starting. Dekat why digital heritage.
Okay, right. Okay, you can see my screen.
Not yet. It's on the way. Yes.
Boleh. Alright.
Yes. Okay.
Okay, all right, done. Okay, Alhamdulillah. Okay, all right. Okay, so with regards to digital heritage and the importance of documenting our cultural heritage, yeah, these are the relevant laws and regulations, yeah. Federal Constitution 1957, UNESCO Convention, and then Copyright Act 1987, especially pertaining to the issues of copyright in digital sort of like data, National Heritage Act 2005, and local authorities, etc. Okay, in the National Heritage Act 2005, there is a clear sort of like a chapter on the role of the commissioner, in which, like, with regards to built environment, the cultural heritage of built environment, and also sites. Yeah, um, I mean, there's a responsibility to promote the conservation, preservation, rehabilitation, restoration, and reconstruction of a heritage site. B, to ensure the proper management of a heritage site, including the use and development of all buildings and lands in the heritage site, and the preservation of the environment, including measures for the improvement of the physical living environment, communications, socio-economic well-being, the management of traffic, and the promotion of economic growth. And the role of promoting schemes for the education of or for practical and financial assistance to owners and occupiers. And part of this whole thing, I mean, the whole thing could not be carried out without the conservation management plan. And what is a conservation management plan? It is kind of a white paper in which that the life of the conservation or the heritage assets are being guarded, from the time that the preliminary report ataupun laporan awal, that detects the defects and with the dilapidation report and things like that, up to the sustainability of the repair, and then to what extent we can prolong the life of this heritage asset. Okay, all right. Okay, heritage projects typically rely on multidisciplinary collaboration. A number of experts and specialists contribute, exchange, and interpret complex information and data about a heritage asset to inform the understanding of its value and significance. This understanding is crucial for decisions on future interventions, conservation, and management. The quality of information for this multidisciplinary knowledge base is crucial for heritage projects. Poor information, inaccurate, incomplete, or uncoordinated, often leads to errors which can be detrimental to the historic asset, its value and significance. Yes, unlike the field of entertainment, or whatever that's unrelated to history or conservation, accuracy is prime in conservation, because like we need to be able to record things as accurate as possible, because if not, it is open to interpretation, and if not, they may be liable for misinterpreting the cultural heritage significance. So these are the important roles in conservation professional practice, from project and contract management, advice consultancy, recording and documentation, repair specifications, or proposal treatments. So these are the areas in which that we come into, meaning to say, like, when we document, or the first step in acknowledging that the cultural asset is important for us is for us to record it and to document its significance. Then only we can deal with all of these other parties. Okay, so what are the issues in the current practice of heritage documentation in Malaysia? At present, information about historic buildings and archaeological sites is usually represented as a collection of individual documents, reports, drawings, computer-aided design, CAD 2D or 3D files, and various data sets provided by different professionals, and then each of them working with their own tools and different standards. Kan? So meaning there's no unified database. If I mean those who have done research, or those who have been trying to find information, will understand this fully, that there's not a single sort of like center that we could gather all of this information, and the accuracy of this information is something which is unknown, and can be questionable in some cases. All right, with regards to movable heritage assets, that means the artifacts, the ways in which collections are assembled and managed once they are part of museum holdings post restriction in the utility of material history collections, which in turn cause limitation to public education and enlightenment. It causes lack of art appreciation among the museum visitors who consider museum environment as boring without engaging activities. Yes, museums have become a place where all things are stored. Yeah, when you go to the museums, dark lightings and then very static way of exhibiting artifacts, to the point that people are not interested to go to museums. Yeah, very few museums are able to attract visitors. Yeah, and to make people engage with the story or the narrative that they're trying to tell. According to, on the other hand, yeah, according to Bonneberg 2019, virtual heritage has limited functionality. So in the case where virtual heritage or AR, yeah, being used, to promote cultural heritage or historical narratives, they have limited functionality in terms of heritage visualization because of too much photorealism and hyperrealism effect in the 3D modeling programming design with limited information about the past. Okay, this is very context specific, this statement, because for example, when I teach history of Islamic art and architecture to my students, many of the video being made, yeah, are made by gamers, yeah. And because history of Islamic art is well written and well documented, they come up with very very good sort of like AR sort of like videos that enable my students to learn. But in some cases, I agree, like there are too much imaginative or imagination going on, to the point that you lose the authenticity of the historical narratives, yeah, in museum collections. Okay, all right. So I would like to share with you all the years of not experience. Okay, this is a disclaimer. I cannot call myself an expert, but I would rather call myself as an academician, and most of all, I'm an enthusiast here of history and also conservation, preservation of cultural heritage assets. Yeah, and I do this because I think it is important as an academician and as educator to educate the society on the role of history, on the role of heritage identity, yeah, and then also to open up the young minds and young hearts. Kadang-kadang tak dah muda sangat, tapi like me, young at heart kan. So like for example, so that they look at technology as a medium or a tool in which that history can be recorded and can be promoted. We do not want to keep history in our backyard or in our dungeon, but we want to promote it as as proudly as possible using the technologies and experimentations that we have at hand. Okay, all right. So this basically my timeline as a person who is enthusiastic or who has deep interest in preservation of cultural heritage assets. So we actually began as far as 2004. Our first research was reconstruction of the earliest mosque in Malaysia using virtual reality techniques. 2004 now to 2022, like 18 years ago, when I was still young lah kan. Sekarang dah berumur lah, right? Okay, and then so that was, I mean, Kampung Laut Mosque was being selected, and it was the first mosque ever, and I suspected at that time it was the first building ever to have been documented using 3D terrestrial laser scanning device. At that time we used Leica. And then 2006, I went for my PhD break, and that was a long break, people. I did mine for almost 8 years, yeah, and came back by then, 2013 and 2017. There were various experimentations, and then we embarked on small projects, especially during that time. There's this software called Autodesk 123D Catch. I'm sure some of you may have heard and may have tried them. Um, and we started our research projects on 3D TLS and photogrammetry, and also the use of 3D prints in promoting cultural heritage assets. So from 2017 to present, we are currently looking at heritage beam, HBeam, scan to beam, beam being building information modeling, LCC, long life cycle cost, life cycle cost for heritage assets, and also accessible museum. So my current interest is in the IoT for heritage, mixed reality for heritage tourism, and also experimental archaeology. Okay, so let me just run through quickly on our experimentations or our research projects. So this is Kampung Laut Mosque. For those of you who are not familiar with Kampung Laut Mosque, which is located in Kelantan, it was first removed or relocated in 1971, if I'm not mistaken, yeah. But due to the big flooding that happened in 1968, Bah Merah, so part of the building, I mean, part of the sites, not just the building. So this image is taken from Arkib Negara Malaysia back in 2004, yeah. And if you see this building here, actually, half of the site where it was originally on has been swollen by the river. When I went there in 2005 and interviewed some of the residents there, they used to mention that, they used to swim in the river and found bones, ya, tombstones, maksudnya apa tu, kubur tu dah tenggelam dalam sungai tu, because with this mosque dia punya kubur ada dua, satu bahagian menghadap ke sungai, ada satu lagi like belakang masjid tu, kalau kita ikut daripada sisi ni lah, if you look from this position, because at that time the river is the main important of the, routes in which the mosque receive its visitors, yeah. Okay, so this was the condition of the mosque during that time. It was already half going down towards the river bank already. Yeah, and you can see the fragile sort of like foundation, and and more than half of the length of the pillars is already underneath the sands and the ground. Okay, so it was moved to Nilampuri, a few kilometers away. And so we decided to record the building which was in Nilampuri and reconstructed, the building as if it was in, its prime time when it was, in Kampung Laut. Okay, so during that time in 2004, this was the technology that we used, the 360,000 degree to 170 field of view, not much different. Only now the millimeter spot size is different, and the accuracy now is 3 millimeters. And so these are the things that were available then in 2004. Okay, but mind you, okay, this is what we know as total station, and we need to use the reflectors and also the help of a group of surveyors in order for us to be able to scan this building. Okay, um, all right. So these were the capabilities of this total system solution from Leica during that time, an ability to capture and then to georeference and to extract and analyze, and finally to deliver the building in terms of 2D or 3D maps and drawings, georeference point clouds or cloud points, yeah, 3D models, dimensions, and coordinate lists, etc., etc. Yeah. So the good thing about this is that when you get the building, you are able to document the building in real time and to document the building as a model already, a 3D model. Yeah. Then it is the other way around. If prior to this, prior to the introduction of 3D laser scanner into the construction scenery, we use AutoCAD. We'll start from 2D. You do a 2D drawing, plan, and then you raise it up, and then you make it into 3D. But with this total solution, is the reverse. You have the 3D modeling, and you're able to slice it this direction, slice it that direction, do a sections, and you can dissect the building in any way that you like. Yeah. The good thing is that you're able to keep this data in order for you to revisit it in the future and for future researchers. Okay, I'm just going to show you what happened in 2004. You can see that all of those surveying sort of like points being placed around the building. And these are some of our team members. On the left is Dr. Hazman Hazmi, who is the my partner during this research. He was originally a lecturer in IIUM, and but he left in 2013 and opened up his own sort of like practice, focusing on 3D laser scanning and also digital documentation. On your right hand side is the service provider or the technological provider. Um, and he was the one who guided us on the use of this technology for the first time in Malaysia. And here you got the preparation of work and briefing. And we also have the help and during that time the cooperation with Jabatan Ukur Malaysia. So you can see there how many people were involved in this exercise. And mind you, the Leica machine for the 3D laser scan was very heavy. I couldn't carry it. Yeah. So it was that technology during that time. Yeah. Like, even this guy here, this is Razak Wong. Um, he's the one who operated the 3D laser scanner, and you can see that he has these big muscles, in order for him to carry uh, the scanner. Okay, yeah, you can count how many people there are. All right, and then so the scan progress and external, and this is inside, and another one, so you can see the points there. Yeah, and this was the outcome. So it was really quite impressive for us during that time. Yeah, you can see all of those points that we wanted to see. You can even see the survey points. Yeah, and yeah. So on your left is the image as captured by the camera of the scanner, and on your left hand side is the 3D cloud points. Yeah, or point clouds you call it. Yeah. All right. So this is the interior scan. You can even see. Okay, one sec. Can you see the people there? Yes, here you can see the people there. The Pati standing, yeah, in the front row of the soft, yeah. Okay, right there. So how does a 3D laser scanner works? This is for those who are not familiar with it. Okay, so you have different points in which that you direct your scanning device and to make sure that they cover 360 degrees and all of the images have to be overlapped, and then so takes more than like 300, 600, 300 images in one go, and then only these images will be registered and merged using the georeferencing system, and then you get the complete scan. Um, just for your information, in our first experimentation of doing this, what happened was that the georeferencing, because it was the first time, the surveying points were not correct. Yeah. So yes, we see these cloud points being sort of like registered, in the system, but actually they were hanging, and you can't really georeference it during that time. Okay. So, but we won silver award for this project in MTE during this time, Malaysian Technological Expo. Yeah. And it was the first time, like, our kuliah won, that prestigious award somehow. So, alhamdulillah. Without them knowing, the problems behind it, of course. Yeah. So, okay. But compared to now, okay, somehow, subhanallah, this Masjid Kampung Laut is really something, a unique project for us because we started with it and somehow now in 2022 and actually beginning from 2021, we got the project again in a sense that Dr. Hasman got I mean, got to become the conservator for the project whereby he had the opportunity to use the 3D laser scanner this time around. And then I am involved with the coffee table book, for documenting the history and then also the process of removing the Kampung Laut back to Kampung Laut box back to Kampung Laut. But look at this quality. This is the 3D scanning cloud points data that you get from a Faro laser scanner, which was done in 2020. Yeah, and the difference is a lot because this is almost photorealistic already. Yeah, and you can see there the details that you want to see, and this is a cut through sections, and you can see the people almost quite realistic. So this is how, like, 20 years have gone, from the first time that we used it, and now this machine is only operated by 2%. Yeah. One will be operating the machine and the other one will, like, just make sure, like, that they set the target points, when in on the site basically. All right. Okay. Second one that I would like to share with you all is in 2013, yeah, when we started to look into the use of image-based reproduction of heritage assets. As you know, 3D scanner, and during that time we purchased it. I mean, the Kulia purchased it in 2006, I think, after we won that award there. And but somehow, like over the years, it became just like a gajah putih, not being used. People complain it's too expensive to run. The software and licenses are very expensive. You need all of those surveys and things like that in order for them to do the work and things like that. So because of that, we were looking into alternative um, methods on how heritage assets can be documented. And heritage assets should be accessible, and it should be meaning to say, like, it should be visitable. You should be able to visit it, at a low cost. Yeah, it should be affordable. Yeah. So if so we look into image-based documentation. Image-based meaning to say, like, if just now we need to use the georeferencing system, and they have to be vector-based, in order for them to be recorded, yeah, because of that 3D laser scanner are precise, yeah. But with image based, you can use any sort of like your digital camera. You can use your iPhone. You can use your iPad. So we started by using an iPad actually. I've lost the images. I was trying to look for it last night, but we tried at first this ayam. We call it ayam. I mean the patung figurines, a small figurine of a rooster, yeah. And then we have these like AutoCAD 123D Catch facilities or apps online. So all you have to do is that you can click now. I mean, you can find out about this in YouTube. So all you have to do is that you make sure that you put the image like on your left hand side here on something that can be tracked by the software. So usually like a newspaper, something like that, then that they can use as reference point. Yeah. So and then you take a 360 degrees image surrounding the object, upload all of these images to the cloud, and then to Autodesk 123D Cache website, and then after a few hours they will return it to you, in the form of 3D model. So during that time, the tagline was like print yourself, meaning to say, if you're able to do that, I mean, you're able to take all of these pictures, of this figurine, upload it to 123D Catch. They will give you this apa tu the 3D sort of like image of yourself or the figurine, and you're able to 3D print it. Yeah. Okay. Um, So this all has to do with the advancement in the computer vision technology, whereby 3D web services and then open source, yeah, softwares are being offered online. So making people able to experiment on this kind of services. Yeah, I'm not going to read through. You can have a read through when it is made available, inshallah. Okay. So even if the range-based techniques are in general more accurate, recent studies found that the image-based techniques are more convenient and practical. Yeah. Furthermore, the image-based techniques, through the use of algorithms derived from CV, computer visions, are able to automatically perform the whole pipeline, reducing time both of images orientation and 3D reconstruction. This approach enables orientation of a very huge numbers of images without any knowledge of the camera parameters and network geometry. Exactly. Okay, so that's what happened to me, meaning to say that, okay, I acknowledge the advantages of using this system from cultural preservation perspective and not from, for example, a computer vision, or from someone who knows ICT very well, or someone who knows about programming. But I know that they can be done, and because of that, we explore these avenues in order for us to find a way of accessing cultural heritage documentation in an accessible way and affordable methods. Okay, so we embark on this project on documentation of the Petala Indra boat, which is a very decorative boat of the Malays. I actually have it here. Yeah, I don't know whether you can see me, but we did 3D print it. Yeah, and So 3D laser scanners use laser technology to deliver highly detailed 3D documentation. 3D images of complex environments and geometries can be generated in mere minutes. It can be used for accident reconstruction, 3D modeling of process plants, architectural preservation tasks, digital factory layouts, or deformation monitoring. Photogrammetry, on the other hand, is the art and science of using overlapping photographs to reconstruct three-dimensional scenes or objects. The practice has been around for over a century, but has become especially popular over the course of the past decades with the proliferation of digital cameras and free of relatively inexpensive but accurate processing software. Okay, so we selected the Patala Indra boat, which is to me during that time an ideal sort of like artifact. One, we cannot call it an immovable artifact because theoretically it can be moved, but due to its size, the length is 4.66 meters, the height is 1.66 meters, and the width is nearly 1 meter. And then also it is a wonderfully carved wooden motif, very complicated in a sense. And we also know that 3D laser scanner works perfectly for almost flat and rounded surfaces, as it has worked, for many of the restoration projects in the European countries, especially for churches, in the reconstructing of the columns, and then their sort of like relief patterns, relief motifs, and the sculptural carvings and things like that. But with Patala Indra, it is a very intricate wooden carving, which I'm going to show to you. And at the same time, due to its size, it is almost immovable that it has to be stored in the apa tu under Jabatan Museum Malaysia, in the storage of the national museums basically, and because it required preservation to be done, so it was out of the view of any sort of like visitors. Okay, all right. So this is there are only I think around 11 of these boats, yeah, left in Malaysia. Okay, and you can see like this beautiful work of art, and like this intricate detailing, and it is 3D, 2D, and everything. So we would like to find out how the 3D laser scanner works in trying to capture all of this detailing, and then also how we can compare it with photogrammetric methods. Yeah. All right. Okay, all right. So these are the specifications. So we have on your left-hand side is the 3D laser scanner. We actually use two laser scanners for this one. One is the long range or medium range Ferro Focus 3D one X130 scanner. The other one is the handheld freestyle 3D scanner, which is a short range scanner. And Microsoft Surface Pro 3 tablet, checkerboard marker tripod, and the software used was Ferrocene and MeshLab. For photogrammetry, we use a normal DSLR camera with a tripod target marker, and the softwares used were Agisoft Photoscan and Autodesk Maya. Okay, so the methodology that we adopted was the uses for 3D laser scanner. The workflow was for Faro Focus 3D scanner involves two major steps. One is scanning process using checkerboard marker around the artifact. Second is data processing, post processing to merge the multiple scans. And then the workflow for Faro Freestyle 3D scanner involves two major steps. Similar, actually, scan with an intuitive plug and play system, capture real-time point cloud visualization data effortlessly of almost any surface type in a wide range of environments. And then the data processing was used using Faro capture and also Ferrocene. Okay, so these are the equipments that we used, and then this was the site. So you can see on your right hand side, this beautiful bird boat, located in the storage. So those are the checkerboards markers, and that is the scanning equipment being put on a tripod, the laser scanner X130. Okay, so another one is by using the freestyle 3D laser scanner. And this one here, we have to go around, and the concept is almost similar with photogrammetry, in which that you have to make sure that the images overlap. Okay. With the Faro Freestyle, through the real-time visualization on the tablet, the intuitive user interface, and the light weight less than 1 kilogram of the scanner, the data acquisition process scan is fast and can easily be done even by semi-trained operators. The scanning is done by pointing the scanner toward the artifact and steadily and slowly moving to cover the whole scan area. The scan data can be viewed in real time within the tablet to ensure all data are collected. The data that have been fully captured will be displayed in green cloud. The data processing for the Faro Focus 3D scanner is done in its own software we call Scene. The multiple scan points that has been captured on site are merged together to form a point cloud model of the scanned object. The software used the checkerboard markers scanned together with the object as reference points to merge the multiple scan points into one. The software also offers tools to manipulate the point cloud, such as deleting unwanted data and colorizing the points cloud model. Okay, so here are the cloud point model of the Patala Indra using the Faro Focus 3D laser scanner. So on your left hand side are the original colors, or the colors we allocated for the different parts. Yeah, and then on the right hand is when they have been colorized in using a 3D view to match the exact color. Yeah, and then this one here, one sec. This is laser scanner for, yes, this is X130. And this one is from the Faro Freestyle scanner. Okay. And you can see the difference in terms of the final output. And then these two information are merged together. Yeah. Okay, and to make sure that they are accurate. Okay, the issues or challenges that we have when we use the 3D laser scanner is that it cannot be too bright. We cannot have the object being put into a bright, sort of like sunlit day, for example. Yeah. At the same time, it cannot have shadows that will sort of like forecast the detail of the vector points, for example. Yeah. So for that reason, we require those two sort of like 3D laser scanners in order for us to be able to mesh them, and then to combine them and to cover for the areas that were not covered by one or the other of the scanner. Okay. So, and once we have done that, with 3D laser scan, is that you have to mesh it, using Mesh Lab, and also to triangulate in the area, like for example, where it's dark and you're not sure what it is, and then you have to mesh it together in order for you to be able to reconstruct. So, meaning to say that although, yes, we use these highly advanced 3D laser scanning methods, but at the same time, you need the human touch there in order for you to be able to join those loose ends together and to mesh them to make sure that they are all joined before you can perform acts such as the 3D printing. Okay, so this is okay. I'll comment about this whole thing after this. Yeah, let me just go through photogrammetry. So these were the equipments that we use: Canon EOS, ATD, and also a tripod, just a normal one. Okay, before we started using DSLR camera, I started this project with my undergrad students. The first trial we tried using iPad, just the normal mini iPad during that time, iPad 4. Okay, uh, we were able to come up with quite a nice 3D visualization in a sense, but we were not able to get the detail, like for example, in terms of like when it comes to lighting, yeah. And then because it was like connected to freeware, on the internet during that time, then we had problem when the internet is down or there's not enough connectivity, yeah. So that was the first try, and then the second one we tried to use iPhone, and then this was the third one where we use a DSLR camera, yeah, with tripod. Okay, so it was set on manual mode, and the exposure level has to be set so that we get a consistently sharp image. Yeah, we need to shoot around 100 to 300 photos depending on the size of this artifact. So the cover, and then also I remember during that time there were three levels that we covered, meaning to say like below, middle, and then higher range. Yeah, and then they must overlap no less than 60% all of these pictures. In order for you to get a full 360 photos of the artifact. Okay. So basically, this sums it off, sum it all. Yeah, like for example, like what are required, in terms of setting up the camera points. All right. So this was my postgrad student together with a staff from Global Heritage Consultancy, the one that was set up in the company that was set up by Dr. Hasman. So you can see, like even without using a tripod there, on my right hand side is my postgrad student, and we were able to, as long as you have a steady hand. Yeah. So perhaps some of you who are an expert in photogrammetry can comment after this. Okay. So okay, those are the data processing, and these are the images on how the photo alignment processes were you know were conducted. And then some unlimited, we have noise, what we call as noise, so points which are not required, because like when we took those images, they may be shadows, they may be like overlapping points, so you need to delete those unwanted points. Yeah. And then we get into the color stripped point cloud, and finally the final 3D model. And when you look at it, not too bad, isn't it? That, to be honest, like if we were to project this, on the screen or use it purely digitally, I think photogrammetry is perfect. There's no problem with it. But if you require accuracy, and then if you require it to be printed, then you have a problem with that. Or if you want to use it, if you don't want to use it purely for visualization purposes, and you want to do more with it, like for example, in the preservation efforts, in order for you to reconstruct missing parts, for example, like that, then we do have a problem when we want to use photogrammetry. Okay. So okay, then we embark on another projects after we have gone through, like, okay, our lessons learned, from photogrammetry and also 3D scan. If you can see, I'm not sure whether you can see, Dr. Mazlina, you boleh nampak tak I punya board ni?
Boleh doktor, boleh.
Can you see my board?
Yes, yes. Audience pun boleh nampak juga.
Boleh nampak ya? Okay.
Mm-mm.
Okay, so this is the small 3D Petala Indra, yeah. But as you can see here, due to the intricacy of the, I mean, this is small, of course, to the intricacy of the patterns, and also um, you can imagine how complex this structure is. And I came to the conclusion that even with the use of 3D laser scanner, um, free help, handheld, or like the X130, yeah, laser scanner, it is almost impossible if we were to reconstruct this, and in order for us to be able to do defects repair, yeah, because with the Malay apa tu wood carving, as you know, they are very detailed, and in order for you to get this detailed sort of like 3D, sort of like scallops, of the bird, you really have to be like, so like get into it, and then you start stitching it together in the mesh lab or something like that. So it requires a high level of capability in order for you to be able to do that. So yes, we do have a challenge in terms of our Malay cultural heritage, especially those pertaining to this kind of assets. Okay, then we embark on scan to BIM. Okay, what is BIM? As you may have known, like BIM is building information modeling, whereby this time around, by using the 3D laser scanner as well, we extended the pipeline to not to just for visualization purposes, and also to print, but also to be used in the construction industry. The building that you are seeing here is Gedung Raja Abdullah in Klang. This is also one of the projects for my final year students, and also a project which was conducted together hand in hand with Global Heritage Consultancy as well. Yeah, and this image was captured, of course, by using the 3D TLS. Okay, it allows the model, to be, I mean, during this exercise, we saw the opportunity on, the ability of the scan data to provide another service. that is on facilities management. If you already have an already like for example like heritage buildings which is already there as built monument, yeah, and you have like for example the number of doors that you need quantity to, or the number of chairs, or the number of pillars, how would you do that? Yeah, are you going to do it manually by calculating each window, what is the dimension, each chair, what is the dimension? And then it is here that we discovered the advantages of scan to beam, meaning to say like by using the 3D terrestrial laser scanner, you are able to record the characteristics, the elements, everything that is in the building or outside the building, and link it to Revit software that will enable you to basically then put it in its classification according to the manufacturing details, and then also to each element details. Yeah, so it is here that we see the highly collaborative process which heritage conservation experts can get involved in, because it became an integrated effort, not only, for those people in the construction industry, but moreover for those people who are interested in preservation of cultural heritage assets. Yeah. And of course, in this stage, we have started to embark on a more advanced sort of like technologies such as the drone, yeah, and then also more advanced documenting equipment in terms of the camera. Yeah. Okay. All right. And these are the pipeline or the workflow whereby the first one you will scan the process using 3D point cloud, and then it's going to be processed using scene, and then this information will be converted using Virtusurf to change it into BIM enabled model, meaning to say that they will be able to be viewed by BIM competitive softwares such as the Revit, for example, and the deliverables are in the form of BIM LOD 100, LOD 300, and above. LOD means level of detail, meaning to say that you're able to sort of like according to the specification of the client and the requirements of the project, you're able to deliver the output of this data into the highest details. Yeah. So the final deliverable is HBIM system, computerized conservation management system. Okay, so for Gedung Raja Abdullah, we have it being scanned by Ferro laser scanner, and then it was changed into point clouds data, and then it was then changed into 3D modeling in Revit, and it is from here that it became a beam enabled model. Yeah. Okay, so these are the advantages of scan to beam compared to the traditional or conventional, whereby you use the AutoCAD to come up with the drawings, and you come up with the 2D drawings, and then you come up with as-built CAD. Then only you bring it to Revit in order for you to make it beam enabled. But by using 3D laser scan, you are able to convert it directly to Revit after you got the 3D model in the cloud points. Okay, so if we look here, there are several buildings which we have already conducted, using the scan to beam techniques. So, for example, the Sarawak State Museum um, took no the Fort Horse in Sarawak took 2 days to scan, and the processing, scan, and modeling take up to 5 days, and you only need 2 persons to do it. Yeah, Sarawak State Museum 6 days, and then 10 days, 5 days scan processing, and then modeling another 5 days. For Gedung Raja Abdullah, you require 3 days, 2 days for processing, scan, and modeling 10 days. Yeah, so these are, you look at the speed, although it may look expensive in the beginning, but the output is unlimited almost. Yeah. So these are the images you get from the 3D modeling in Revit. And then 3D animation using Naviswork. Yeah, and this student that joined Global Heritage, in order for her to in her internship, and also for her to come up with this final project. she was able to come up with a 3D model of this building using 3D printing. Okay, all right. So these are the advantages of the scan to beam, whereby, like, not only that, by using the 3D laser scanner, you are able to create a library, yeah, of that heritage buildings, things that which were not able to be done by just normal measured drawing methods or photogrammetry, yeah. So you're able to, like, for example, the doors, windows, furniture, all of those, yeah, were able to be recorded, and there will be a library that you can refer to. And this also allow you to conduct analysis more efficiently, and the data can be used for asset management system, for design data, for schedules, and also for collaborations. Yeah. Okay. So those are, the yeah the advantages and then the superiority of 3D laser scanner if you compare to other methods. But I would like to come up to this explorative project that we had with my postgrad student now, but then she was Miss Hajida, yeah, Hajida Fauzi. She did this project for her final year project when she was in final year, what, 2, 3 years ago? Yeah. So she looked into the 3D print for accessible museum, in which that she looked on how museum should be more accessible, to people, including those who are old, children, and then those who are unable or handicapped, like those who are blind. So by using tactile art, she would like to discover on how painting, or something which is 2D that we usually display, on the walls of the museum, would be able to be enjoyed by those people who are less able. Yeah. So here, as you have seen here, is this tactile theme being used by an artist to replicate. So in normal circumstances, you cannot touch, the artifacts in the museum, because they're kept in the glass, because you cannot touch them, because there are dangers for you to transfer all of this salt and moisture that will further deteriorate the object. Yeah. So what do? We will replicate it using 3D printing. But then what is it for? So that it can be enjoyed by other people, especially here where this lady here is wearing the headphone, where she can listen, to the history about this artifact, and she can feel it. So in this project, Hajida came up with the idea of coming up with an interpretation of a 2D drawing, so that 2D miniature painting, so that it can be enjoyed by the people of limited visibility, meaning like blind people. Yeah. So what she did was that she came up with these 4 prototypes, in which of different sort of like dimensions and level of solidity, meaning to say like 3D characteristics. Yeah. So rose number 1 is high relief, as you can see, like full relief, whereas like rose number 4, which is green, like almost flat, but still you can feel. Yeah. And she want to test this on she tested this already on selected participants, so that they could so that they can so that they can acknowledge, okay, what is this, and they can appreciate it, and they can express their feelings of what they want, if they were to sort of like experience this kind of artifacts in a museum environment. Yeah. So Hajida has chosen Pahari School Indian Miniature Painting. Okay, you may be asking why Indian miniature painting. In our department, we teach miniature painting to our conservation students because it was an art that was popularized during Mughal rule in India, and it is also, the Pahari school Indian miniature painting absorbs the Islamic influence in their in their paintings, and you can see the effects on how, like, for example, the beauty thing is that there a combination of objects in the scenery. You have the person there, you have the background, and then you have buildings sometimes. So Hajida have chosen this particular painting here because she wanted to experiment with the texture. She wanted to experiment with the depth of the painting. So it requires her to be able to interpret, this sort of like painting, and to to be able to read, people sort of like preferences, when they feel the painting, when they are unable to see by themselves. Yeah. Okay. So these are the process of making the 3D replication, where at first she will trace the images into the different apa tu, in Corel Draw Illustrator. Mind you, she has differentiated the different components, yeah, and then she will import them. I mean, she imported them into ZBrush, whereby she used it to mask the individual parts and things like that, and then to sculpture and put more details. Yeah, and finally she export it into an STL punya apa tu, um, conversion. Yeah, and then in order for it to be able to be printed. Okay, so these are the tracings of the 2D miniature paintings using Corel Draw, and this is the image of the woman. Yeah, you can see the details of the earrings, even the body posture, and then the textile sort of like her curvature, even the textile trips, and then you can see like the jewelry that she's wearing, and at the back is, for example, the trees, the texture of the trees. So this was the final output of that. From here, if I can go back from there, yeah, which was the 3D miniature painting, which is 2D and flat, and to this one here. All right. So I mean, you can imagine, like, the various sort of like opportunity that this technology gives us. And during her final presentation for her final year project, what Hajida did was that, to let people feel this painting, and at the same there was also audio behind that, people can listen to, in order for them to understand the significance of the painting. Beautiful, isn't it? Yeah. Okay. So you can see there the detail of it. And thank you, Assalam. So I think that's the end of my presentation. So what I'm trying to do here is just to um, give you an insights of the endless opportunities that we can do with regards to uh, 3D or digital technology, and especially when it is embedded into heritage, So I think with that, I end my session, and I pass back to Dr. Mas, so that we can start the session. Yeah.
Okay, thank you, Dr. Harlina, for giving such informative and interesting presentation. Okay, so ladies and gentlemen, now we come to question and answer session. So if you wish to ask a questions, you can simply type your questions into the chat box, and I will read it out. Okay. Okay, actually, we already have questions daripada Dr. Nizam, Dr. Khairul Nizam. Okay. The questions is, Doctor, is this kind of 3D documentation appropriate for the 3D printing?
Dah terjawab lah kan?
Dah terjawab tadi dalam apa
The
ni?
final one
Maybe
tu.
Doctor can explain more
Mm-mm.
about the significance of this 3D documentation ni.
Exactly. Yes. Yes, actually, like, if you want to bring it towards 3D printing, the only thing that you have to make sure is that all of the gaps, or the points are closed. They have to be meshed. So that's why, like, we have to bring it to mesh lab in order for us to be able to make sure all of the joints are nicely, triangulated. Yeah, then only we can send it to print. So usually it will take a few steps, like, I mean, you can contact the 3D, those who operate the 3D print, and you can send your STL file, and then they will advise you as to whether, like, we still need detail for this one or whatever. Yeah, because they will know whether, you know, it can be printed or not. Like, for example, as I have shown to you this, this yellow sort of like Petala Indra. Yes, it can be printed, but you don't get the details, yeah, because of the meshing, and also because of the intricacy of the scallops, that need human hours to be put in order for you to able to join those things together. Yeah, but I mean, this is one of the avenues in which preservation of cultural heritage assets are getting into, and actually we are a bit behind if compared to the European countries. So you can look into, if you want to search, look into accessible museums. You look into, yes, the pipeline 3D printing and cultural heritage. Yes, you'll find lots of information on that one. Yeah.
Okay, thank you. I hope the answer will apa ni, memuaskan hati Dr. Khairul Nizam. Okay, we have another questions here from Ismail Ma'ruf. Okay, very good sharing, Assistant Prof. Dr. Harlina. Okay, what accuracy requirements you are required to use this method? Does cost greatly affect the expected accuracy, and is this method so simple? So, what is your opinions based on your experience?
Okay. Uh, Okay, Assalamualaikum, Dr. Ismail. Good to see you online. Yes, I mean in terms of 3D laser scanner, in terms of the cost that involves, yeah, it involves first the cost. I mean the software, yeah, the licensing for the software. So if you want, like they usually provide you just with one or two softwares, and then like the equipment itself like cost now. I mean the latest was I think a quarter of a million dollars, 250,000, something like that. And then the software requires renewal. I think that's the part in terms of hardware. Another cost that will be incurred upon will be on the expertise. I mean, people who are able to operate the 3D laser scanner and also are able to, for example, to translate or to convert, the 3D cloud points into the different sort of like softwares which require it. So the cost, that is where the cost is, meaning to say like up to which level do you want it? Do you want it just for just visualization purposes? Like for example, if you do that, I mean, we have a okay. Actually, there's another research going on, on how they use cloud points as an artistic sort of like product. I mean, as you have seen, because the cloud points, they themselves are, I mean, they look like quite nice, yeah. So how they have used that in order for them, to come up with this visualization of the heritage objects or whatever objects that they want to portray. So if you want just up to the cloud points, yes, you can get up to there. So that is where the chain of or the pipeline stops, yeah. But then if you want further, and then you want to, for example, beam, and there's a level of detail like LOD 100, 200, 300, 400, and things like that. So the level of details is depending on whether you want just a 2D drawing and 3D drawing, for example, or LOD 200 is in terms of, I think, the 3D modeling of it, and LOD 300, 400, you start to have MNE inside of it, yeah, and then things like that. Yeah, so depending on that, then there will be different expertise that we have to come in, because BEAM, for example, requires a concerted effort or collaborative effort. Then there will be more people in the industry that we need to consult, and of course the cost will be more. So it's not so much about the accuracy, because the equipment itself is already almost accurate now, like nearly 2 millimeters accuracy. But then it's about the expertise and the manpower that, and also the people involved in the pipeline, and to what extent do you want to continue with the people are willing to pay for that service, yeah. As to whether it is simple or not, depending on your expertise, of course. As you have seen, like in the beginning in 2004, we require the service of many people. We work together with Jabatan Ukur, and then like you also have the the vendor helping us, to operate. We even need help, to carry the thing around, the equipment. But now, currently, Dr. Hasman's company only have two main personnel, yeah, operating the 3D laser scanner. Yeah, so he is, I mean, that was my ex-student also, Rafiq Hafizuddin. So he is the expert in, scanning the building, and then also to transfer the building data, the cloud points, into the various requirements. And then only at the end, like, if you need it up to Revit BIM, then we require another person, of course, yeah. But if it's just up to visualization, Rafiq can do it. And you have seen just now when we were comparing, the speed in which, we did the buildings, just 2 days, 10 days, less than 2 weeks in most cases, for example. So that was the speed. If we want to talk about ease, it depends on the expertise that we have. Yeah.
Okay, thank you,
What
Dr.
else?
Harina, very brief answer from that question. Okay, we have another two question here. Okay, from Mariam Abdullah. Okay, Dr. Salam, Dr. Harlina, can this 3D
Salam.
scanner be used for documenting intangible culture heritage, such as scanning the stage of wayang kulit performing art?
Yes, this must be your friend, yeah, Doctor.
Yeah, I think so.
Mazlina. Okay, good question, Mariam. Actually, we talked a bit with, I mean, me and Dr. Mazlina before we started, because yes, it is. When you talk about intangible heritage, all tangible heritage are accompanied by intangible aspects of it. It is whether you want to acknowledge them or not. That's it. If you choose to acknowledge it, yeah, then you must find ways on how you can materialize this intangible aspect of that cultural heritage. I will give you an example. Um, Based on our research on the traditional Malay house in Malaysia, yeah, and when we studied the 13th Malay house archetype, yeah, we can see some kind of stability and consistency there. When we look further into, like, the components of this Malay house, the Malay wood carving, for example, sits nicely within the structure of the traditional Malay house. And when we look further and study further, we found out that the all of this Malay house design and also all of their wood carvings are all interconnected or all designed perfectly according to a precise geometric constructions, namely dynamic proportional rectangles. Okay,
Mm.
so and we conducted. Okay, I must pay respect and tribute to credit to Dr. Hazman again, because that was his PhD. But I mean, he conducted on more than 40 sort of like panels, wood carving panels, yeah, and all 40 of them conform to the dynamic rectangle proportioning systems. So these dynamic proportioning systems are something that you do not see, but they are there. But if you do not publish them, if you do not do something about them, people will never know about it, for example. So this is where our roles come. Like, we are the enthusiasts, and then we are very sympathetic, to our cultural heritage. So in the case of the wayang kulit performing art, what story that do you want to tell? So first of all, you have to find your own narrative. How do you want to present this the significance of wayang kulit performance? Do you want to present it in the form of the story that it brings? Do you want to present it in terms of, like, for example, the people behind the scene? Do you want to present it in the form of the technologies used in order for you to come up with the in Kelantan, for example, the kulit is transparent and colored. How did they do it? I learned from one artisan in Kelantan that they use a special method in which that diorang peram kulit tu dalam mud. Tanah tu kena tanah sungai. And ada tempat tertentu aja yang dia boleh peram kulit tu, so that it has this translucent effect. You know? So those things, if you don't document it in such a way, they will be gone. So
Yeah, true.
now we need to think on how are we going to present this intangible or unseen knowledge of the Malay people. Yeah. So once we identify that, then we must understand also, we must look for a method on how we can so like make it materialize or make it tangible. Yeah. So we were talking like perhaps we can use 3D, we can use the technology of AR, VR, mixed reality. Yeah. Macam people can do Pokemon Go, kan? Like, for example, just by using your tab and your phone, and then, like, you can just look into it, and then you can chase this Pokemon wherever you go. Why can't we use that the same technology? For example, when we look at wayang kulit, we can imagine, people playing it, like, the dalang, ataupun orang yang tengah buat dia, kan. So at the same time, orang dulu-dulu tu pakaian dia macam mana, we recreate the scene yang kat stage tu, macam mana tradisi orang main wayang kulit waktu tu, just by the equipment that we have, the iPad je cukup dah. Tak payah nak guna Google ke apa. So I think these are the things that we should think forward to, because I think yes, there are opportunities to menghidupkan balik this intangible ataupun materializekan these intangible aspects of the tangible assets. I hope I answer your question, Mariam.
I hope so. I think she already faham, understand what you are answering the questions. Okay, is it we have another questions? I think yeah, another question. I think this is the
Dr.
last
Ismail.
question. Yeah, still from the Dr. Ismail. Okay, what are your comment on what are differences between LOD generated through TLS? There is very technical, I think, and
Mm-mm.
for photogrammetry based on the result obtaining on your previous finding.
Oh, a lot. Uh, I don't know. I mean, Dr. Ismail, you are the expert in photogrammetry, right? You have your PhD in, so perhaps you can add up to that one. Because photogrammetry is image based, so if there are a kind of details that goes into it, it will be in terms of the specification of the camera, and then also the software that you use in order for you to mesh the images, things like that. But they are not vector based; they are image based. Unlike 3D laser scanning, they are vector based and they are also georeferenced. To GIS basically. So meaning to say, like, they are real data. There's no room for, almost there's no room for errors, because what you see is what you get, what you capture is what there is, and it is a live document when you put it into BIM environment, because other parties are able to contribute to this live information. Yeah. So when it comes to level of details, yeah, yes, the level of details are different, and this level of details are not, I don't know, okay, correct me if I'm wrong, but I don't think they are existent in photogrammetry. Yeah, because when you talk about LOD, it requires you to be able to make it beam, beam friendly or beam able, and then you will have to put it into the Revit software basically, and then, like, you're able to come up with all of these schedules. And with that also, yes, you, Dr. Ismail, you're a surveyor as well, right? Then you're able to, like, for example, come up with the bills of quantity. You're able to, link with the manufacturing details. You're able to come up with, like, for example, a library. There's another PhD student that I remembered. I'm not sure whether he has graduated or not, that he come up with his own library of heritage beam, in which that he input, but he did not use laser scanning. He just input the images or the data about Malay istana, yeah, or Malay traditional architecture into the Revit sort of like library. The idea was that so that people can assess it. The problem with that approach is that the lack of accuracy. Whereas, like, in the preservation of cultural heritage assets, the accuracy is number one. And if you look at any of the regulations or law or bylaws, or UNESCO sort of like guidelines, it has to be accurate in order for you. Then only you will be able to say, yes, you have done justice to the heritage assets. Yes.
Okay, thank you, Dr. Harina, for answering those questions. I think we about a time. Okay, great. Thank you, everyone. Finally, we come to the end of an end part of our webinar. I would like to thank you again to Dr. Harlina for the
Thank you
informative
so
and
much, Dr.
interesting
Mazlina.
sharing today. And also to the audience, I very appreciate for your active participations. Hopefully, our webinar will be beneficial for everybody. Before we leave, please make sure you have filled in the attendance forms that available in the in the comment chat text box. And thanks again for joining us today, and I hope to see you next time. Assalamualaikum warahmatullahi wabarakatuh, and take care and stay safe. Thank you very much.
Okay, Waalaikumsalam.